Now today, here you see this is a question on Bernoulli's principle. Figure this shows a siphon, which is a device for removing liquid from a container. Tube here, this is A, B, and C, must initially be filled, but once this has been done, liquid will flow through the tube until the liquid surface in the container um, is level with the tube opening at A. Means flow until this the liquid surface comes to this point. Onto this point, the liquid will start flow, will go on flow, will flow through this pipe. Now liquid has a density this much and negligible viscosity. The distance shown here, this is h1, this is A, B, and C point, and distance here, this is h1 is 25, D is 12, and h2 is 40 centimeter. With what speed? Now, with what speed does the liquid emerges from the tube? C. If the atmospheric pressure is 1.0 in 10 to the power of 5 Pascal, what is the pressure in the liquid at the topmost point B? And theoretically, what is the greatest possible height h1 that the siphon can lift water? So here we are going to use the Bernoulli's principle. So according to Bernoulli's principle, pressure energy, potential energy, and kinetic energy per unit mass remains constant at every cross section throughout the liquid flow. So according to your Bernoulli's principle, this is according to Bernoulli's equation. Bernoulli's equation, your P pressure plus rho V square rho GH kinetic energy potential energy is constant. So let us consider at any point on the surface of the liquid, D is the point on the surface of the liquid. See, D is the point on the surface of the liquid, and C, this is the point at the outlet. So now we are going to apply this Bernoulli's equation at point D and C. So this will be how much? PD plus half rho Vd square plus rho G, your this HD is equal to pressure at C and plus half rho Vc square plus rho GHC. So now here you say these are open to the atmosphere. So this is PD is equal to PC, that is equal to P air, that means pressure, air pressure. So atmospheric pressure, because it is open to the, at both the end it is open to the atmosphere, so it is equal to the atmospheric pressure. So here and here the pressure is the same at PD and PC, this is P air. So this and this cancels out. Now here velocity at D is 0 because it is still, so here this is also 0. So you are left with that is rho G HD minus rho G HC is equal to rho VC square. So here this will be how much? Sorry, half. So here again rho cancels out, so this will be 2 G, that will be 2G HD minus HC, and this will be equal to VC square. So this, so here root over 2G your HD minus HC, this will be equal to VC. This will be the velocity. Now you see D, this point, and this point C. The difference between HD, this point and this point, you see, this is the difference in height. This is the difference in height between D and this is the difference. So here this will be equal to 2G D plus H2, that will be equal to VC. And D plus H2, this will be, because here you see the difference in height is D plus H2 between D point, and this is the D point and this is the C point, high. So now when you place the data, that is equal to 2 into 9.8, 9.81, D is how much? 12, and H2 is 14, so 12 plus 40, it is 40, so this will be equal to VC. Now this will come up to how much? 2 into, let us for our convenience, instead of 9.8 let me take 10, and this will be how much? 52 into 52 is equal to VC. This will be your VC. So this comes out to be 52. Let us do the prime factorization of 52. 2 2s are 4, 2 6 are 12, 2 13. So this comes out to, let us take the help of a calculator. Let me tell you, here the unit is how much? This centimeter. So this will be point, and this will be also 0.40. So this comes out to be into 0.52. This will come out to be, because it is in centimeter, so you have to convert into meter. So your answer comes out to 2 into 10 into 0.5 to 10.4. So so your root 10.4, it comes out to be, that is 3.2 meter per second. This is your VC velocity. This is your velocity VC. Now this is the first part, and for the second part, that is, if the atmospheric pressure is this much, 1 into 10 to the power of 5 Pascal, what is the pressure in the liquid at the topmost point B, at this point B? So again I am going to apply the Bernoulli's equation, that at B and at C. So B and C, so PB plus half rho VB square plus rho GHB, this will be equal to PC plus half rho VC square plus rho GHC. Now here you see one thing is there, that is the you have to find the if the atmospheric pressure is at this much, what is the pressure? Because PC, it is open to air, so PC will be equal to P air, and that will be equal to how much? 1 into 10 to the power of 5 Pascal. This will be, again now here you see velocity VB is equal to VCY from continuity equation, that is, because you see they are of same size, so A1 V1 is equal to A2 V2, means here the pipe is of same size, therefore cross sectional area is the same, so here and here the velocity will be the same. This is from continuity equation. So here continue, we have to find PB. So now here your this and this cancels out, because velocity are equal, so you are left with how much? PB. You have to find the pressure at B, so this will be how much? PC plus rho GHC minus rho GHB. So here you see PB is equal to PC and plus rho G, it is common, HC minus HB. This will be your, so here you see uh, HB is this much, so and HC is this here. So here you see the difference in uh, um, HB minus HC, because B is at higher point, so HB minus HC. Here you see that your HB minus HC. Here you see that your HB minus HC. This is HB minus HC. This is how much? H1 plus D plus H2. This is HB minus HC. This is, but since here it is HC minus HB, so it will be negative. So PB, that will be equal to PC plus rho G, and this will be how much? 25 plus 12 plus 40. So this comes out to be 25 plus 12 plus 40. So this comes out 77. That means it is 0.77 meter. So this will be how much? Here, since it is HC minus HB, so this will be minus 0.77. Now when we place the value, that is 1 into 10 to the power of 5, your rho density is given to you 1000. G is your 9.8 and this is 0.77. So this comes out to be 1000 into 9.8 into 0.77. So this comes out to be 1 minus 7546. So when you subtract it, 1 0 0 0 0 0 minus 7546, it comes out to, this is 92454. That means 9.2454 into 10 to the power of 4 Pascal. This is your answer, 9.4. This is your answer. And last, theoretically, what is your, that is the greatest possible height h1. This will be how much? This is P air divided by rho. This much, maximum will be this much theoretically. So P air is 1 into 10 to the power of 5 Pascal, and the density is your how much? 1000. So it comes out to be 10 this is in meter, all unit are meter. So this will come out to 10 meter. So h1 you can rise maximum 10 meter. So now again I am going to repeat the same. So here you see, this is a practical instrument which is used for to remove water from a container by the help of the pipe. So here we are going to use the Bernoulli's equation. So according to the Bernoulli's equation, pressure plus this kinetic energy plus this potential energy, this is constant. So at first we apply this at these 2 points D and C. So here you see D and C, this is your equation. Pressure at D, it is open to air, and this at C, it is open to air, so it is the pressure here is the same. And again here there is no velocity on the surface of the water, so your Vd is 0. So we are left with this. Now Hd minus Ht, see difference is high, Hd minus Hc, this is your difference. Hd minus Hc, this is your difference. So here this is equal to d plus H2. So velocity at C will be this much. And for the second case, pressure at B, again we are going to apply this Bernoulli's equation, and you see that uh, your PC, which is open to air, so it is air pressure, this will be atmospheric pressure, and from continuity equation your VB is equal to VC. So when you place here you see your difference HC minus HB. Actually HB minus HC, this is this height, this is the difference in height, HB minus HC. So this here, but since it is HC minus HB, so it will be minus, and when we place here we get this much Pascal. And lastly, theoretically you can raise H1 to this much 10 meter. So this is all about this question, and it is solved on Bernoulli's principle.